we are going to look at what the ID gas calculation. So I want to give you the various formulas you use to solve the ID gas problem. They are going to look at 4 to 6 questions, different questions you are going to see in the exam. So you want to pay close attention. So when I talk about ID gas, you say what P V equals to what N R T. Now, this equation is a very useful equation that you can use to solve the pressure of the gas, the the volume of the gas. Then you can use to what get the molar mass of the gas, the mass of the gas, and the density of what of that gas. So this is what the general equation. So this is the first equation we want to look at. So you have PV equals to what N R what T. Now remember N P equals to what the pressure. So let's find it. P equals to what pressure, and the pressure must be what in ATM. You get the pressure must be in ATM. Then V is what volume, and it must be in what in dm cube or what liter. The same thing. Dm cube and liter that was the same thing. Then N equals to what numbers of mole. N equals to what numbers of what moles. Then R is what is the gas constant. Gas constant. Right there. Gas constant 0.0821 ATM liter per mole per what Kelvin. Then T is what is the temperature of the gas. And the pressure must be what in Kelvin. So you don't want to what pay close attention to this one here. You can pause the video and copy them out. Very, very important to take them. So with that now, let's break this down. Remember, M is what mole, and mole because of mass, or what molar mass of the gas, right? So in the place of N, I want to replace one here. So if I should replace it there, you have P V equals what mass, or what molar mass, times R what T. From here now, let's make mass the sorry formula. But if I should cross multiply, here I have mass times what RT is equals to what PV times what molar what mass. So there are two things we can do. You can either make mass the formula or molar mass the formula. If I should make mass the subject of formula, so if I should make mass the sorry formula, here I'm going to have divide both sides by what RT, right? So I'm going to have mass equals to what PV times what molar mass over what RT. This is what the second formula you can use in ID gas calculation. So PV times molar mass over what RT. Now what about if you make if you make molar mass formula? Divide goes by PV, P what V. Zero cancel this one here, right? So you have molar mass of the gas equals to what mass times what RT over what PV. Get that? So it means that here we have molar mass equals to what mass times what RT over what PV. So that is it. So from this place now, you know that PV equals to what mass or what molar mass times what RT. Now what about if you say you calculate density of the gas? How you going to do that? Remember, density is equals to what mass over what uh, volume, right? Mass by volume. So what we want to do here is to what make volume the subject of formula. If I should make a volume the subject of formula here, I want to have mass here is sorry, volume is equals to what? Mass over what? Density. Mass over what? Density. So what you want to do here? What I want to do here is what? Anywhere I see my volume, I put what? Mass over what? Density. So here I can say, yeah, V. Right? So V equals what? Mass over what? Density. So here we have P times mass over what? Density here equals to what? Mass over what? Molar mass times what? R what? T. Remember the goal here. Remember the goal here is what? Make this formula here. So when you cross multiply, what happen here? This times all of this. So it will be D times mass times what? RT equals to what? P times mass times what? Molar mass. Do you get that? So if you make this formula, then I'm going to divide both sides by this one here. So it's going to be mass times what? R what? T. You have mass times what? R what? T. So this will cancel out this will cancel out this, right? So I'm now left with D equals what? P. So mass will cancel out mass too. You get? So it's going to be P times what? Molar mass over what? R what? T. So this is going to be what? My fourth formula. D equals what? P times what? Molar mass over what? R what? T. So these are all the formulas we are going to use in this video, and you should commit them to memory. If you know you cannot derive them yet, so commit them to memory because we are going to use this one to solve most of the questions you are going to see in your exam. So now let's start solving question. Now let's solve this question. You have to copy it at, then follow me closely. I say that at 500 degrees centigrade and 699 tall, the density of sulfur vapor is 3.71 gram per liter. Okay, so this is what density gives to us. So what is the molecular formula of sulfur under this condition? So you want to actually know the molecular formula of sulfur under this condition. So first you want to do to calculate what the molar mass of the gas. Calculate what the molar mass of that gas. So solution. Now temperature is what? 500 degrees centigrade. Now for every calculation you must cover what? Degree centigrade to what? To Kelvin. So it's going to be 500 plus 273. So which is going to be 500 plus what? 273. It will be 773. 773 what? Kelvin. Next thing you want to look at is what? Is the pressure. Pressure, here we have 699 torr, right? And you must convert torr now. Pressure must be what? In ATM. Pressure must be what? In ATM. Um, Pressure can be measured in what? In millimeter mercury, torr, or Pascal. You get, or kilo per Pascal. So, but when it comes to the ideal gas equation, the unit of pressure must be in what? ATM. So, whatever unit shall be given, you need to convert to what? ATM. You get. So, we have a relation that what link all of them. Here we have 1 ATM because of what? 760 what? So, because of what? 760 what? Millimeter what? Mercury. Then equals to what? 101325 Newton per meter watt square. You want to take some out, you get. So then we are going to use what? 1 ATM because of what? 760 what? Torr. Because I'm going to convert torr to what? To ATM. So I have to take it from down. Now, when you are converting 1 ATM because of what? 760 what? Torr. So when you are converting, what you want to do here is to what? Say times. Now, this ATM will be at the top, and it must be at the down. So I turn and turn what to go at, you get. So what I have left is what? 1699 times what you get like this. Here I have 699, so 699 times 1 equals to by what? 760. Here I have 0.9197 ATM. So then we're going to be what my equation. My equation now what's ATM. The next you want to look at is the what density given to me. So the density is equals to what? 3.71 gram per watt liter. So gram per watt liter. You want to calculate what the molar mass of the gas, molar mass of the gas. So this is what I'm looking for. Of course, we are going to use this one here. Now the main reason why I use this one here because here I can easily calculate the molar mass of the gas. Yet we know what the density of the gas. Here's what is gas constant, and we know what temperature. Remember, gas constant here, RO is equal to what? 0.0821 ATM liter per mole per watt Kelvin. Yeah, so I want to write this place because I don't think we need this stuff again. I don't want to water this one here because we are still going to make use of all this formula. So I don't stress myself much. So let's demarcate this place. Now what we want to do here is what? D. So D is equal to what? P times what? Molar mass over what? R what? T. Make this formula here. What will happen here? P times molar mass equals what? D times R what? T. Right? So make the molar mass formula here. Divide both sides by what? P. So my molar mass is equals to what? D times RT over what? P. What I want to do now is what? Impute what? My values. My density is what? 3.71 times RT is equals to 0.082 times T is what? 773 over P is what? 0.9197. So what I want to do is to punch your calculator and get your answer. So let me also write this one because we are done with it. So if you punch your calculator here, we have 3.71 times 0.0821 times 773 divided by 0.9197. So here we have the molar mass of the gas. It's equals to what? 256.02 gram per watt per mole. This is what? Remember, the unit of what? Molar mass is always what? Gram per mole. I don't want to do the unit analysis because we don't have time here. Gram per mole. Now, you have to what? Know the numbers of atoms of sulfur present here. The atomicity is equals to what? The molecular weight, which are calculated over what? The atomic weight of what? Sulfur. Right there. So remember, sulfur is what? Is 32. The molecular weight is what? Is 256. So if you impute it here, 256 over what? The atomic mass of what? Sulfur is what? Sulfur is what? Is 32. If you do that here, we have 256 divided by what? 32. Here we have 8. So my atomicity, remember atomicity is what? Is the numbers of what? Atom in a what? In a molecule. So to get the numbers of atom in the molecule, Remember, we have calculated what the molecular weight of that sulfur vapor. Do you get? So we want to get the numbers of atoms of that sulfur in that vapor. You get? So that is why we divide this one. We divide the molecular weight with what? The atomic mass of sulfur. After getting that, here we have the atomicity. The atomicity is equal to what? 8. So the molecular formula is equal to what? X what? 8. So the key point here is to therefore calculate what the molecular weight of what of that compound, then divide it with what? With what the atomic mass of that element. So that way you are going to know what the numbers of atoms of the element in that compound. Then you just have to what try the molecular weight here. You get. So this is how to what to get to solve one. Let's look at question 2. Question 2. 2.00 gram of what? Nitrogen gas are placed in 5.0 dm cube container at 25 degrees centigrade. What is the pressure of the gas? So what we want to do here is solution. Write out what your parameters. So mass was given to me. Mass equals to what? 2.00 gram. Right? So the volume was also given to me to be what? 5.0 dm cube. Temperature was given to me to be what? 25 degrees centigrade. Right? So remember, temperature must be converted to what? To Kelvin by adding 273. So 25 plus 273, 25 plus 273. Here we have 298. 298 what? Kelvin. What is next here? We want to get the molar mass of the gas. We want to get molar mass of the gas. Molar mass of what? N2. It's very easy here. The atomic mass of nitrogen is what? Is 14 times 2. So it means 14 times 2. What do you have here? 14 times 2. Here we have what? 28 gram per mole. So which other thing here? My hour is what? 0.0821 atm dm cube per mole per Kelvin. So I don't need any other again. What I'm looking for is the pressure of the gas. What are we going to use the calculate here? We are calculating what the pressure, and you are giving mass here. It means that we are going to use this guy. Mass equals to PV times molar mass over what? RT. So using mass equals to what? PV times what? Molar mass over what? RT. If you should what? Make what P so formula when it equals multiply, here we have PV times molar mass equals what? Mass times what? RT. Divide both by what? Molar mass are what? And V times what? Molar mass. V times what? Molar what? Mass. So this will cancel out this. This will cancel out this. What will be left with is what? P equals what? Mass times what? RT about P times what? Molar mass. So this is what you are using. So please take it down. The next you want to do is to what? Impute your formulas. So P is equals to what? Mass is what? 2.00 times R is what? 0.0821 times the T temperature is 298 over V is what? 5.0 times molar mass is what? 28. So we can wipe the whole board now. So we wipe the whole board. Here we have 2.00 times 0.0821 times 298 divided by 5.0 times 28. So your P is equals to what? 0.34958 You find answer straight. So you don't do it individually, you just push everything into your calculator and you want to get this answer. So let's look at what the next question. Let's tackle this problem. Here. It said what a gaseous sample weighing 0.896 gram was found to occupying a volume of what 524 cm cube at 730 millimeter mercury and 28 degrees centigrade. First, what's the molar mass of the gas? B, suggest what gas the sample is. So it's from what the molar mass you calculate. You are going to what suggest uh, the gas is going to be. Solution. So let's tackle it here. The first one to this what write out what your parameter. So mass was given to me. Mass is equal to what 0.896 gram, right? Now the volume was given to me, but it was in what in cm cube. Remember when you're solving ID gas, the volume must be in what in dm cube. So it means that I have to convert this cm cube to what dm cube by dividing by what 1000 because 1 dm cube is always equal to what 1000 cm cube. So here we have the volume equals to what 524 cm cube times. Now here we have 1 dm cube over what 1000 cm cube. So as cm cube cancel as cm cube, right? So divide by 1000. So what you have here is going to be 0.524 dm cube. Next you want to look at is what is your pressure. So P which is what 730 millimeter mercury. Now you have to work right to ATM. Remember, I did gas the pressure must be in what in ATM. So remember 1 ATM is always equal to 760 millimeter mercury. So going to be times. Now here we have 1 ATM here. Then here we have 760 millimeter mercury. So millimeter mercury we can cancel what millimeter mercury here. What will be left is what this times it divided by 760 961 0.961 ATM. Get that? Next is what is my temperature. So I'm going to write it from here. I'm going to use this one. Temperature T equals to what 20. T equals to what 25 degree centigrade. Remember, I'm going to convert this one to what to Kelvin. So by adding 298 Kelvin. So you want to calculate molar mass of the gas. How do you calculate molar mass? You are going to use the formula that relates mass, volume, and what pressure and temperature, and that is going to be molar mass is equal to mass times what RT what P. So this formula what we are making use of. You want that is what substitute your values. Molar mass equals to what is my mass? Mass is what 0.896 times R is what okay R is always 0.0821 times T is 298 over P is what 0.961 times V is what 0.524 0.524. So what you want to do here is what punch your calculator. Punch your calculator and get the answer. Here we have molar mass is equal to what 43.53 gram per mole. which is approximately 44 grams per mole. So now the gas that comes to my head that is having 44 azote, the molecular weight is what CO2. CO2. If you calculate what the molar mass of CO2, you're going to get 44 grams per mole. So the suggested gas is going to be what? CO2. So that is for this video. I don't want this video to be too lengthy. So if you enjoy this video, please leave a like, leave a comment, and subscribe to the channel if you have done that. Thanks for watching. See you in the next video.